welcome back. I'm going to step away from the physical construction of pinball machines, or deconstruction as in the last video, and go back to how we got here and the design that we're using for this Bally to LED conversion. We made it look pretty simple in the first couple of them, just stick the board in, turn it on, and everything works great. But Mike and I have actually been working on this for at least 2 years now. And we've had a lot of false starts, poor designs, and changes of thoughts along the way to get to where we are today. So I'm going to take you through a little bit of that history, explain the problems we made, point out some things that I doubt very many people understand about how the Bally light driver system works in their pinball machines. And then we'll bring you up to where we are today. Show you the current light driver board and maybe the one we have on the drawing boards for a more final product. So with that, let me move over to a screen capture, and the rest of this video is going to show you the screen capture. I'm not going to record my face like I did in some of the other videos, just because it's a little difficult and I want to knock this out kind of quick. So here you go. We are on my computer, and I have up a copy of the schematics for the 8-Ball Deluxe pinball game, which I downloaded from the internet, from the ipdb.org website. Which is a wonderful resource, and if you don't know about it, you should check it out. It has all kinds of great information on pinball machines. So I downloaded a copy of the schematics for 8-Ball Deluxe, and the reason I have 8-Ball Deluxe here and not the 8-Ball that we're actually working on is because when we originally designed the board, we designed it for 8-Ball Deluxe. The 8-Ball Deluxe game is more complex. It has a lot more lights. So it uses an auxiliary driver board, and one of the pins off of the auxiliary driver board drives a relay board. So all those things had to be taken into account when we were doing our original design for the replacement of those light driver boards. So I have the schematic up, and I will page down to the light driver board. So this is the light driver board. The connectors on the right-hand side, J1, 2, and 3, are the connectors that go out and feed all of the switched lights on the play field and in the back box. Next to that on the left are the SCRs, and those SCRs are solid-state switches that actually turn the lights on and off. Or they turn the lights on, and then they turn off when the current through them goes to 0. To the left of that are some 4-bit to 16-bit decoders, and those are used to select the individual light that you want to turn on. And those decoders are driven by 4 address lines on the far left there on J4, and 4 data lines, and a strobe. So when I first saw this schematic, I thought to myself, picking up this data is going to be really easy. I just watch for the strobe, I latch in the address and data that they're displaying there, and I know which lights are being turned on. Well, I was really wrong about that, and it took me a few months to actually figure out how this circuit actually works. And so that's the little nugget that I want to get to you guys today, is how this circuit actually works. The strobe that comes in on pin 13 here only latches the 4 address lines. These 4 address lines come in, and they attach to the 4 data lines on the 16-line decoder, the 4-line to 16-line decoder. So they get set and they get latched on the input register when the strobe occurs. Then, sometime later, after the strobe has already gone away, the data line will activate two, maybe all four of these data lines will activate, and that will turn on the enable pins on these chips, which will let whatever address was selected, let its pin go high on the output. And when that occurs, the SCR latches on. The SCR is the data latch. The data bit, the trigger for that SCR is the data bit. So you basically have two independent latching systems here. The U1 through 4 latch the address, the SCRs latch the data. However, when I was trying to interface to this, the only thing I had available to me was the data coming in on these pins on J4. And actually, it isn't J4, it's J1 on the microprocessor. I'll take you over there in a few minutes and show you that. But so I had to figure out a way to actually capture all of this data. And I'm not going to go into how that occurred in this video today. I just want to let you know that it did occur. And that it was something that had to be overcome. So you can think about, if you were designing a circuit to do this, how would you accomplish that? Now you got to realize that you're trying to accomplish this while also updating LED strings and putting them out to the world and handling all of this input data, which occurs asynchronously with respect to your computer. I mean, it occurs whenever that computer wants it to occur. And while the address lines are clocked, and you can use that clock to clock in that data, the data isn't clocked, so you have no idea when it's going to happen. All you know is that it's going to happen before the next strobe. Now, to make it more complex, there's another light driver board. This is the auxiliary light driver board. And it's a little different in that it only has a 3-bit to 7-bit decoder set of chips as opposed to a 4 to 16-bit decoder like the original light driver board has. So it only uses 3 of the address lines, but they still get latched in the same way, and then the data comes in, enables the output, which turns on the SCRs and turns on the lights on the output. So that was the problem I needed to overcome. Let me take you to the computer board. So here we are on the computer board, and if you look on the far right hand side in J1, that is the upper left hand connector on the microprocessor board where you saw us plug our board into. And up on the top of that jack, you see the lamp and address data bits, and then just below that you see the 2 lamp strobes. Lamp strobe 1 goes to the primary board, lamp strobe 2 goes to the auxiliary board, but then there's some other pins on there that go to other places. So we couldn't just disconnect this connector and plug our connector into it. We had to pass the rest of that data through our board so that it could still get out to the displays and other things that got displayed. And the one last thing I wanted to show you on here, if I can find it real quick, was right down here. This is on the main board. Pin 11 of J3 actually goes out to the auxiliary expander board, and that's a relay expander board. So we had to design onto our board a way to connect up that relay expander so that we could drive that relay expander board. So all of that was taken into account in our design, and I will go over that in more detail later. So thanks a lot for watching this. See you shortly. Bye-bye.